Hello. Hi.
Hello. Yeah, we'll start, right?
Yeah, we are in live. You go.
Yeah, sure. So I will start sharing the screen. Hello. Yeah. So hello. Can everybody hear me?
Yes, ma'am, it is audible.
Yeah, sure. So we'll start. There are a few questions from the mock that I've taken. So all those who want to solve, so I will just share my screen. As far as I can assume you all know the rules and all. So have you all joined using the code? Okay. Yeah, sure. So we'll move to the question. So this is the first question. I will give you 5 minutes to solve this first. After that, if you have any problem, I can explain the question. Can you mute yourself?
आए
Hello. Please. As of now, I've received only 2 responses. So 2 more. After that, I will close the responses. Okay, so I have received some 15 responses so far. Anybody else who want to who is solving? All of you, please write your answer here deck. Don't write your answers on chat box. I will stop taking the response now. Okay. All of yeah. So I will explain the question to all of you. So the question is, a machine learning model detects whether the given image is an image of a dog or not. And it is found that given an image of a dog, the model predicts it to be a dog in 95% of the cases. On the other hand, if the image is not actually a dog, it shows the image to be dog in 30% of the cases. Now, if you have an image that you have randomly selected from a group of 100 images in which 40 are dogs, and if the machine learning model predicts it as a dog, what is the probability that it is actually the image of a dog? So, first of all, we'll see what all information is given to us.
Hello everyone. Those those who are not joined this peer deck, please join because I'm seeing 79 participants here, 84 participants here, and only 45 participants are joined peer deck. So others also can please join. And the code for joining the peer deck is BFYJKY. Go to
Machine
joinpd.com and
learning
type this code.
model detects whether the image given is a image of a dog or not. It is found that given an image of a dog, the model predicts it to be a dog in 95% of the cases. On the other hand, if the image is not a dog, it shows the image to be dog in 30%. Suppose the image is randomly selected from 40 odd dogs. Machine
So,
learning
yeah.
model predicts it is a dog. What is
Hello.
the probability that it is actually a dog? Machine learning model detects whether the given image is a
No,
Who is
just
speaking on
given
the
if
image
it
is
is
the
you are
image
saying
of
it
a
is
dog.
difficult to
It is found that given
peer
the image
trade,
of a dog, it
just
is a
go
dog
to
in
your
90% of
Google
cases.
Chrome or whatever browser you are using. Just type joinpd.com. You will direct to that peer deck and just
If
need
the
to
image is
enter that code
not a dog,
BFYJKY. It's not that difficult.
it shows the image to be dog in 30% of the
Oh,
cases.
somebody is
Mohan Raj,
speaking
can
on
you
the
mute?
background. Mo Damodaran, please mute yourself. Okay, so we'll go to the solution now. So what do we have to calculate here? So the question that is being asked here is, if the machine learning model predicts it as a dog, what is the probability that it is actually a dog, right? So the question is, like, you have given it here, like machine learning model predicts it as a dog, and you have to find the probability that it is actually a dog. So let's take the events. Let's take A denote the event that the machine learning predicts the machine learning model predicts the image to be of a dog. That is given to us, right? That, yeah, that is given to us, and now we have to find the probability that it is actually a dog. So let's take the event B that denotes the image is actually a dog. Now let's see what all information is given to us. So the first information, yeah.
Ma'am, YouTube link. Okay. Got it.
Yeah, okay. So let's see what all information is given to us. So given here it is written, it is found that given an image of a dog, if you have the image of a dog, the model predicts it to be a dog in 95% of the cases. It means if you have the image of a dog, the machine learning model will predict in 95% of the cases, that is probability A given B is 0.95. That is what given to us. The second thing that is given is if the image is not actually a dog, it shows the image to be a dog in 30% of the cases. So if the image is not actually a dog, so we had taken the event B as image is actually a dog. So B complement will be the event that the image is not actually a dog, right? So we have given if the image is not actually a dog, the model predicts it as a dog in 30% of the cases. So you have probability A given B complement is 0.30. Now the third information that you have given here is an image is randomly selected from a group of 100 images in which 40 are dogs. So probability that the image is actually a dog is 0.40. So that is given to us. Probability of P is 0.40 and probability B complement is 0.60. Please mute yourself. So what do we have to calculate here? So we have to find what is the probability that it is actually a dog if the model predicts it as a dog. So it means we have to find probability B given A. So in order to do that, we need to use the Bayes theorem. So the probability that the image is actually a dog given the machine learning model predicts it to be dog is given by P B given A using Bayes theorem. This is nothing but probability A given B into probability of B divided by total probability, that is probability A given B, probability of B plus probability A given B complement, probability of B complement. Now all that information, probability A given B, probability A given B complement and probability of P, all this information is given to you itself in the question that we have written it here. You just substitute the values and you will get 0.38 divided by 0.56, that is 0.6785. So this was our first question. Is it okay for everyone?
Yes, ma'am.
Okay. So we'll move to the next question now. So this is again from the Bayes theorem. So I will give you again 5 minutes. So we'll wind up
Three
at
colleges
7:55.
XYZ are participating in a
Please
competition
mute
where
yourself.
30% of the participants come from X20Y.
Siddharth.
Please mute yourself, guys.
Yeah. So by 7:55, I will again discuss the solution. And don't write your solution on the chat box. Please enter your responses in the peer deck itself. So in this question, you have to write the options. So it is multiple select. So you write using the comma separate or in whatever options you find it to be correct. Write it in the peer deck. Don't write it in the chat box. another 3 more minutes. I'm seeing very less response here. So all of you can try. And don't write your answer on that. Okay, so everybody done?
Hello, ma'am.
Yes.
How can I submit the responses on pd.com? Just I attach the answer.
Yeah, you just write your options, whatever is true.
Okay, thank you, ma'am. Okay.
Yeah. Okay, so I have already got some 44 responses. So is anybody else who is still solving? All right. So we'll go to the solution now. Everybody done?
Yeah.
Okay. Yeah. So we'll see this question. So it is again an application of Bayes theorem. So in the question, it is given that students from 3 colleges, say X, Y, and Z, have participated in a competition. So where 30% of the participants are from college X, 20% of the participants from college Y, and 50% of the participants are from college Z. And we know that another information that is given to us is that 50% of the participants from college X are girls, 40% from college Y, 40% of the participants from college Y are girls, and 60% of the participants from college Z are girls. Now you have to select the correct statements from these 4 options. So first, let's see what is the first option. So there is a 53% chance that a randomly selected participant is a girl. Now, if you pick up a random participant, so what is the probability that that participant is going to be a girl? So how do we solve this? So first, let's write all the information that is given to us. So, okay, 30% of the participants are from college X, 20 from college Y, and 50 from college Z. So let's say X, Y, and Z represent the events that a randomly select student is from college X, Y, and Z respectively. So probability of X, it means probability that a random participant that we have picked from the that random person to whom we have picked from the participant is going to be 0.30, that is given to us, 0.20 for Y and 0.50 for Z. Now let's represent the event G that a randomly selected participant is a girl. Another information that is given to us is if the participant is from college X, the probability that the participant will be girl is 0.50. If it is from college Y, the probability that that participant is going to be a girl is 40%. So this is nothing but our conditional probability, that is PG given X. It means the participant is from college X and that participant is nothing but a girl. That probability is given to be 0.50. Another thing is probability G given Y, that is also given to us to be 40%. It means 0.40. And probability G given Z, it means the participant is from the college Z and the participant is a girl, is 0.60. That was given to us, 60%. So we have the first option. If we see, it says there is 53% chance that a randomly selected participant is a girl. So how do we find that? So we have to use the law of total probability. The probability of G will be probability of G given X. It means the participant is from the college X and it's a girl, into probability that the participant is from college X, plus same thing plus probability that the participant is from college Y and it's a girl, into probability of Y, plus probability of the part G given Z into P of Z. All the information, it was already given to us, so we'll just substitute. So probability of G given X was given to be 0.50, probability of G given Y was 0.40, probability of Z given Z is 0.060. So we just substitute everything and we'll get 0.53. So the probability, it means P of G is 0.53. It means the probability that a random participant that you have selected, picked is going to be a girl is 0.53. So our option 1 will be correct, because it says there is 53% chance that a randomly selected participant is a girl. So option A is correct. Option B says there is a 74% chance that a randomly selected participant is a girl. So we have already calculated that it's 53%. It means 0.53 probability. So option B will be incorrect. Now the third option says if a girl is randomly selected, the probability that she is from college X is 0.283. It means we have to find out the probability that if you pick up a girl from all the participant, what is the probability that that girl is from college X? So again, we have to use the Bayes tool, Bayes theorem. So let's say this is Px given G. It means you have picked up a participant and you found that participant to be a girl, that is given to us, and you have to find out that that participant is from college X. So P of X given G is going to be P of G given X into P of X divided by probability of G given X into P of X plus probability of G given Y into P of Y plus probability of G given Z into P of Z. So all that, so this is nothing but the denominator term that you are seeing here is nothing but, please mute. So Dara, please mute yourself. Okay, so
Madam, you mute from your side, all participants.
yeah. Okay, so as you can see, the denominator term here is nothing but P of G. So P of G is, we have already calculated previously. This is nothing but P of G, that is Pg given X into P of X plus G given Y into P of Y plus Pg given Z into P of Z. So we had calculated it to be 0.53. So the denominator term is going to be 0.53. G given X into P of X, we have calculated to be 0.15. So after calculation, you will get P of X given J is 0.283. It means if you have randomly picked a girl from all the participants, the probability that that girl is going to be from college X is 0.283. So the option, let's see the option. So the option C says, if the girl is randomly selected, the probability that she is from college X is 0.283. So this option will be correct. And similarly, it's the same thing, option D. So we have received the probability to be 0.283. So option D is incorrect. So our options are A and C. Is it clear to everyone?
Yes.
Can you use the contingency table to solve this problem?
Sorry?
Can we use contingency tables to solve this problem rather than going
The
using
person
Excel?
you are speaking with
Yeah,
has
you can
put your
solve
call
using
on
the,
hold. Please stay on the line.
yeah.
நீங்கள் பேசும்
Please
நபர் உங்கள் அழைப்பை
Renalini.
ஹோல்டில் வைத்துள்ளார். दयவு செய்து लाइनिल காத்திருக்கவும். आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर
Nalini.
रखा है. कृपया लाइन पर बने रहें. The person you are speaking with has put your call on hold. Please stay on the line.
The option is not there.
நீங்கள் பேசும் நபர் உங்கள் அழைப்பை ஹோல்டில் வைத்துள்ளார். दयவு செய்து लाइनिल காத்திருக்கவும். आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें. The person you are speaking with has put your call on hold.
Ma'am, you
Please
can
stay
remove
on
him.
the line. நீங்கள் பேசும் நபர் உங்கள் அழைப்பை ஹோல்டில் வைத்துள்ளார். दयவு செய்து लाइनिल காத்திருக்கவும். आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें. The person you are speaking with has put your call on hold. Please stay on the line. நீங்கள் பேசும் நபர் உங்கள் அழைப்பை ஹோல்டில் வைத்துள்ளார். दयவு செய்து लाइनिल காத்திருக்கவும். आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें. The person you are speaking with has put your call on hold. Please stay on the line. நீங்கள் பேசும் நபர் உங்கள் அழைப்பை ஹோல்டில் வைத்துள்ளார். दयவு செய்து लाइनिल காத்திருக்கவும். आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें. The person you are speaking with has put your call on hold. Please stay on the line. நீங்கள் பேச
Hello.
Yeah, ma'am. Continue.
Yeah. Yeah. Thank you. So somebody asked something.
Madam, we have used the base theorem to
Contingency table. Yeah, we have used the base theorem to solve this problem.
we can use the contingency table to solve the problem.
How did I solve the question?
Lecture 7.1 touches upon I think base theorem is the one way to solve this problem. If you use contingency tables, what is taught in 7.1 lesson, that's much faster and quicker. That's the reason I'm just trying to find out, unless there is a special outlier or like special case, only base theorem must be used, or any other mechanism we can use. That's the question, madam.
So you got the same answer, option A and C. What is your option? What is your answer?
A and C,
Okay,
madam. 53% that randomly selected part.
okay. Yeah, okay.
Thank
So
you.
we'll move to the next question. If time permits, we'll come back to this again. Okay. So this is the next question. So we have given the probability mass function for a discrete random variable, and another random variable is defined in the way that is y is equal to x times x minus 2, x minus 3. So you need to find p of y equal to 0. So this is pretty easy. I will give some 3 minutes. After I will start the solution. If he hasn't joined the peer deck, please use the code that is on the top of the screen.
Hello, ma'am. Hello, ma'am. Is it audible?
Yeah, you're audible.
Yeah, ma'am. After this session, means after the end of these questions, can you discuss one of the problem if we wanted to, or you means is it possible?
You want to discuss the problems from mock only?
From mock only. I'm
Okay.
just at the last point. I'm getting confused in that. So I wanted you
Which
to
question?
please help. Just a moment.
Yeah, sure. After we can
Yeah,
take the
this.
question.
After this, yes. Sure,
Yeah.
I will wait for
Okay.
you.
Yeah.
Yes, ma'am. Thank you.
So we have received some 46 responses yet. And all of you who have attended the peer deck, please do join. I can see only 8 participants there. Okay, so we have received some 50 response. Everybody done?
Yeah, done.
Yeah, okay, so see the responses. Fine. So this is so the probability mass function is given to you for the random variable x. So for the for x equal to 0, 1, 2, and 3, your p of x is taking the value 0.1, 0.4, 0.1, and 0.4. Now you have to find another random variable y that is given to be equal to x times x minus 2 into x minus 3. So first we have to check what all values y can take. Let's see. That was given to us that x is taking the value 0, 1, 2, 3. So we just substitute the values of x into the function y and we will obtain the value of y. What all values y can take, we will get from the values of x after substituting its value in the function. So when x was equal to 0, we know that the function that we have to find out is y is x times x minus 2 x minus 3. Now y is equal to x times x minus 2 x minus 3. Substitute the value of x equal to 0 into this and we will get 0 times 0 minus 2 into 0 minus 3, that is nothing but 0. If you substitute x equal to 1 in the equation x times x minus 2 x minus 3, you will get the value 2. If you substitute x equal to 2, you will get again 0, and for x equal to 3, again you will get 0. So for x equal to 0, for x equal to 2, and x equal to 3, we are getting y equal to 0. And only for x equal to 1, we are getting y equal to 2. So we can say if x is taking the values in 0, 1, 2, and 3, if x is taking the value 0, 1, 2, and 3, y is taking the value 0 and 2. So let's see what we have to find here. We have to find p of y equal to 0. So p of y equal to 0 means p of x times x minus 2 x minus 3. So because y was given to us as x times x minus 2 x minus 3, we just substitute it here and we will get p of x equal to 0 plus p of x equal to plus p of x equal to 3. That is nothing but p of x was given to us in the question. Let's see it here. So x equal to 0, p is taking the value 0.1. For x equal to 1, it's 0.4. X equal to 2, it's 0.1. And x equal to 3, it's 0.4 again. So we just substitute those values here and we will get p of y equal to 0 as 0.6. So this was our answer. P of y equal to 0 is equal to 0.6. But the actual question that is given in the mock is you had to find the cumulative distribution function of y. So as we know that y is also taking the value 2. So if you calculate, you will get p of y equal to 2 as 0.4. So the cumulative distribution function that you will obtain for the function y is, for y less than 0, it's going to be 0. For y Lying between 0 to 2, it's going to be 0.6 that we have calculated here. And for y greater than equal to 2, we know it's going to be 1 because we need to add 0.6 also in this case. So 0.6 plus 0.4 is going to be 1.0. So the cumulative distribution function of y will be this term. That is f of y is for y less than 0 to 0. Y lying between 0 to 2, including 0 is 0.6, and for y greater than equal to 2 is 0.1. So this was the question that is actually in the mock. So is this question clear to everybody?
But the cumulative distribution function is difficult to determine. I didn't understand how we arrive at it. Although I understood 0.6, y equal to 0 is 0.6 probably. But how to determine f of y? That I
F
thought I
of
didn't
y.
understand.
So
Can
you
you
know
just
that,
elaborate?
right? So if x is a, if you have a discrete random variable, it is nothing, the cumulative distribution function that you will obtain is nothing but a step function. You must have seen the lecture. Okay. So
Yes.
yeah, so f of 0, if you take, f of 0 is what? F of 0 is p of y less than equal to 0. So for p less, so it means f of y is p of y less than equal to, sorry, f of 0 is p of y less than equal to 0. It means p of y less than 0 plus p of y equal to 0, right? So that is, we know p of, for y less than 0, it will take 0. And for y equal to 0, it is taking 0.6 that we have calculated here. And y is only taking the value 0 and 2. So from 0 to 2, left from, from 0 to less than 2, it will take the value 0.6. But at the point 2 and greater than equal to 2, it will take a jump, and it will, the value that it will take at 2 is going to be 1. Because you
So
can
that
see y is only taking 2
one
values.
value is coming because we add 0.4 to that 0.6.
Point
For y
0.4
greater
plus
than 2.
0.6. You just add and subtract there to find the probabilities, right?
Okay.
Function. Okay, how do we know y equal to 0 and 2? So in the previously I had explained here that x is taking the value 0, 1, 2 and 3. You can see here that x is taking the value 0, 1, 2 and 3, and the corresponding, okay, you got it? Thank you, Anshu. Okay, so we'll move to the next question here. Let's try this out. So again, we have a discrete random variable, and the PMF is given to you. This is this function p of z equal to z is e to minus lambda, lambda to power z by z factorial. Z is taking the value n union 0, so 0 is including the natural number. Otherwise, it's taking the value 0, and lambda is a parameter. Parameter, you can say it as some real number. Now, you have to find the expected value of 1 by 2 to the power z. So it's 8. I will give you time till 8:30 to solve this question. Any of you who haven't joined the peer deck yet, because I can see there are some 112 participants who has logged in here, but only 84 people are logged in into peer deck. So please do log in using the code that is given on the top of the screen. I have received very less responses yet. So I will give 2 more minutes to solve, talking about the question, then we will do solution. Okay, so still very less response. I've received only 26 out of 90 people. So, okay, we'll move to the solution. Let's check who all answered. Option A, option B. Okay. So let's see the solution. So you have a discrete random variable. So the PMF is given to you, that is P of Z. Z is your random variable, discrete random variable. And the PMF is given to be E of e to the power minus lambda, lambda to the power Z divided by Z factorial. And Z is belonging to natural number union 0. And otherwise, if Z is something, some other value, it's going to be, probability is going to be 0. Now you have to find the expected value of 1 by 2 to the power Z. So we will use the definition of expectation here. So as you can see, Z is taking the value 0, 1, 2 up to so on. And P of Z equal to 0 is given by e to minus lambda, lambda to the power Z by Z factorial for Z belonging to 0 union natural number. Now we know that if for any random variable, for any discrete random variable, expectation of the random variable, so in this case it is Z, so expectation of Z will be sum over Z into P to the sum over Z into P to the into probability of Z equal to Z. So the you need to find the question is find the value of expectation of 1 by 2 to the power Z. So the formula for this will be expectation of 1 by 2 to the power Z is sum over Z varying from 0 to infinity. So you need to write, so here it was Z. So in this case, we will write sum over 1 by 2 to the power Z into probability Z equal to Z. Okay, just substitute the values. Let's see. So expectation of 1 by 2 to the power Z is sum over Z equal to 0 to infinity 1 upon 2 to the power Z into probability Z equal to Z. You know, it is given to you, probability Z equal to Z was e to the power minus lambda, lambda to the power Z divided by Z factorial. So we'll substitute the value. So when Z equal to 0, it's going to be 1 upon 2 to the power 0 into e to the power minus lambda, lambda to the power 0 divided by 0 factorial plus when Z equal to 1, it is 1 upon 2 to the power 1 into e to the power minus lambda, lambda to the power 1 by 1 factorial plus up to so on. You just substitute the values of Z in the given expansion, in the given sum, and we just write it here. So you can see that e to the power minus lambda is common for each of the term. First term you can see e to the power minus lambda is here. Second term also you have e to the power minus lambda. Third term also you have e to the power minus lambda. So on. You will have e to the power minus lambda for all the terms. So we'll just take it out, e to the power minus lambda. And let's see here. So this is, if you take the e to the power minus lambda outside, you will, the thing which will be remaining in the bracket is lambda to the power 0 by 2 to the power 0 into 0 factorial for the first term, lambda to the power 1 by 2 to the power 1 into 1 factorial for the second term, lambda to the power 2 divided by 2 to the power 2 into 2 factorial for third term, and so on. So you can write lambda by 2 together. So lambda by 2 to the power 0 into 1 by 0 factorial, lambda by 2 to the power 1 in 1 by 1 factorial, lambda by 2 to the power 2, 1 by 2 factorial, and so on. So just go back to the equation. So let's see here. You must have studied in the class the expansion of e to the power x, where x was a real number. So expansion of e to the power x was given to be 1 plus x square by 2 factorial plus x cube by 3 factorial, and so on. This was the expansion of e to the power x. So if you see this expansion of e to the power x and see this term, so if you take lambda to the power 2 together, like lambda to the power 2 as x, so you will get x to the power, say, let's say lambda by 2 as x. So it is x to the power 0, 1 upon 0 factorial, that is nothing but 1. So this term is going to be 1. This whole first term is 1. Second term, if you see, it is 1 by 1 factorial is 1 again, and it will be lambda by 2 only. So 1 plus lambda by 2 plus lambda by 2 whole square to 1 by 2 factorial, it resembles the expansion of e to the power x. So where there we had, in place of, here we have x, and in this case we have, in place of x, here we have lambda by 2. So this expansion is going to be e to the power lambda by 2. This is the expansion for e to the power lambda by 2. So e to the minus lambda term we have taken outside. So e to the power minus lambda, e to the power lambda by 2. It's going to be e to the power minus lambda by 2. So the correct option will be option B. Is this clear to everybody? Okay. Now, Damodaran, it's not clear. Okay. Definition of e to the power z. Okay, I will say it again. So just go back to the question. So see, in the question you have given the hint e to the power x expansion, right? So e to the power x expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial, and so on. This is the expansion of e to the power x, where x is your real number, right? You must have seen this expansion in the class lecture. So if you go back to the question that was given to us, you have to find the expected value of 1 by 2 to the power z. So when we tried to solve it, we got e to the power minus lambda by 2 to the power 0, 1 upon 0 factorial, plus lambda by 2 to the power 1, 1 upon 1 factorial, plus lambda by 2 to the power 2 plus 1 upon 2 factorial. If we move on, we will get lambda by 2 to the power 3 into 1 upon 3 factorial. So the terms in the bracket, it resembles the expansion of e to the power x. So this is, let's see, so lambda by 2 to the power 0 is going to be 1, right? And 0 factorial, you know, it's 0 factorial is 1. The first term is going to be 1. Now, the second term, if you see, the 1 factorial will be 1, and we will be left with lambda by 2 to the power 1, that is lambda by 2. So 1 plus lambda by 2. Third term, you see, it is lambda by 2 whole square into 1.2 factorial, right? So 2 factorial remains same, and lambda by 2 square. So 1 plus lambda by 2 plus lambda by 2 square into 1.2 factorial plus lambda by 2 to the power 3 into 1 upon 3 factorial, and so on. It will go on like that. So if you see this expansion of e to the power x, you have 1 plus x square. So 1 is the same. In place of x, we have lambda by 2. In place of here, again lambda by 2, we had lambda by 2 whole square divided by 2 factorial, lambda by 2 whole cube divided by 3 power 3 divided by 3 factorial. It's the same thing. So this expansion is going to be e to the power e to the power lambda by 2. Okay, wait. Did you understand this now? Yeah, who is there?
What I didn't understand is,
Yeah.
see, from P of Z, it's possible to find expected value of Z.
Sorry? I
If
didn't.
we are given
Yeah.
given P of Z, it is possible to find expected value of Z.
Expected value?
Of Z.
Yeah.
But here the question is asking for expected value of 1 by 2 to the power of Z.
Yes.
So
So if you see, like we'll go back to the first, I think third question. Go back. Yeah, there if you see, the variable you have changed, right? Y. Not this one. Okay. See, we have to find the expected value of 1 by 2 to the power z. So the probability will be same. The z is taking the value from 0 to infinity. The probability remains the same for z equal to 0, z equal to 1.
Ma'am, in question, it is given that we can only take natural values when we use e to the power minus alpha.
They can only take natural value. Sorry.
Natural
Maybe
numbers.
yes,
Okay.
it is natural numbers. 0 to infinity.
0 to infinity I have taken, right?
And 1 upon 2 to the power Z means it's a random variable which is going to take
Yes,
values
yes.
of Z from 1 to infinity. Correct, ma'am?
Z is taking the value from 0 to infinity.
Yeah, correct.
So you must have seen this expansion in the class of e to the power x, if I'm not wrong. Ma'am has done this expansion e to the power x in the class.
It's binomial expansion.
Yeah, Taylor series, yeah.
Ma'am, in question here it is given that z is the value of natural number union 0.
Yeah.
So we are using
Here I am assuming n is from 1 to infinity. So you can add 0 also here. That is why I've written n union 0.
But ma'am, here we are using 1 by 2 to the power z, which is not a natural number.
No,
Sorry
z
to
is
interrupt in
taking the
between.
value. Z.
Ma'am, by when will the solution will be provided in the PDF format?
Solution will be provided tomorrow.
Okay, ma'am. Thank you.
Yeah.
Ma'am, in the expectation formula, you're multiplying 1 by 2 power z into p of z equal to z. I didn't understand that.
Yeah.
It should be 1 by 2 z equal to 1 by 2 power z.
No.
P
It
of
will
z
be
equal
P
to
of
z.
Z equal to Z. It will be P
Because
of Z
they've
equal
asked
to Z only.
P of z equal to 1 by 4 is my doubt.
Yeah,
The
so
expectation formula
probability
is
Z is taking the value
x
from
into
0
p.
to infinity. So the probabilities will be same.
No, I just didn't understand why you are multiplying by p of z equal to z. It should be,
See, if
we
you
have been
take any
asked about
function,
expectation of.
if you take any function, say x is a random variable, and you have given the probability of the random variable, of say probability x is equal to x is given to you. Now, if you take any function of x, so here 1 upon 2 to the power z is nothing but a function of z, right? So if you
No,
take
this
any,
part
say we had X. So
the
if you
second
take
part I
any
didn't
function,
get. P of
When we look at the previous
equal to Z
sum,
is what I
we
get.
did
yeah,
x into x minus 3 into x minus 1. In that one, the
yeah,
probability didn't change. We just changed, in this sum, the
yeah,
probability didn't change. We just changed the y part. So we have
yeah,
to take only z.
yeah, correct. So if you take the function of Z, the probabilities remain the same. Okay, we'll come back to this question again if there is any. So this part is clear why this expansion in the bracket term is e to the power minus e to the power lambda by 2, right?
Oh, I got it.
Okay, okay. So we'll move to the next question. So, okay. I will give the time till 8:56 around. Take some time.
Hello, mom.
Yeah.
Good evening. I
Good
had a
evening.
I had a doubt in one of the questions, the framing of the questions. Can I ask here?
This question?
No, no.
Some other question you're talking about?
Yes.
Yes, ma'am. I'm
Just the
also.
framing. I just want to.
Which question?
It is mock test question 9.
Correct.
Mock test question 9.
Please,
We'll come
one.
back to that question. Okay, we'll come back to that question. First, let's focus on this one.
Okay, mom.
First, solve this, then we'll move to that question.
Ma'am?
Please solve this question first.
No, I have a question. The question, like question 5. Number
Okay,
minus 1 refers to the number on the die minus 1, right?
Yeah, yeah.
Okay.
Solve this question first.
Morning.
Okay, I have received very less response. Oh, 19 out of 94 people. I will wait for wait till 9 o'clock. That will process.
Hi Nikita, we have another live section. Hello.
Hello? Yeah.
We have another live at 9 o'clock.
So, do we have to stop this?
I think so because we have another live at 9.
Okay, okay. Okay, okay.
Yes. CT
So,
is.
okay, okay, okay. Sure.
Yeah.
So,
Yeah.
guys, we'll just quickly go through the solution of this. So you have another live session apparently at 9 o'clock for CT. So we'll have to wind up this session. So you have the solution, sum of score. So you have to find out the expected value of x, where x denote the sum of scores obtained after throwing of die twice. So you will find first the probability, that is 1 by 5, and so the possible scores that you will get after throwing the die twice is all this. So you will find the respective scores according to all that. So x will take the value 0, 2, 4, 6, 8, and you will find the expected value of probability for all those values. And these are the probabilities that you will get. So you'll find the expected value. Next question. Okay, we'll have to wind up the session actually. So otherwise it will be late. So, okay, we'll wind up the session. You can keep solving. Okay.
Ma'am, could the PPT be uploaded?
Ma'am, I'm having a doubt. Hello, ma'am, are you there?
Yeah.
Ma'am, that question number 9.
We'll have to wind up the session. CT is getting late.
Just a moment, ma'am. Please. Question number 9.
Solution.
Can you just
No,
give
ma'am.
the final answer?
There's a problem in the wording. Hello,
Sorry,
ma'am.
we'll have to. Hello. Yeah, we'll have to.
Question number, please, ma'am. Question number 9.
Okay.
Why denote the number of children in family of a
Yeah,
randomly
there.
selected?
Okay, so there in that question, you have, if you select the children, so what is the, like, if you select the children, how many children will be there in the family of that child? That you have to figure out.
That will be same as X, no?
Yeah, same as X. Yeah. Okay, I will leave the meeting.
Can you give the final answer for this question? Just the final answer.
Yeah, please, ma'am. Just orally you can say.
It was 4.8.
Okay.
4.8, ma'am.
She left, I guess. She left the class.
Hello. Yeah, this is Mayur. So yeah, maybe she left it, I guess, because there another session is going to start. So what about you? Which question was this?